Welcome back. Today, we've got a fantastic explainer lined up for you. We're going to look right past the drywall, past the glossy finishes of modern architecture, and go straight into the skeletal system of a building. We are decoding the anatomy of a roof, specifically looking at Astino structural steel components. If you've ever wondered what keeps those massive commercial roofs from sagging, or exactly how a vast warehouse manages to stand up to extreme weather year after year, well, you're in exactly the right place.
When you really think about the sheer, real-world scale of these Astino structural frameworks, it's honestly breathtaking. But here's the thing. A macro structure of this magnitude is entirely dependent on the micro-level engineering of its individual parts. For contractors, architects, and builders, understanding the exact specifications, the shapes, and the connective tissue of these steel components is absolutely crucial. A massive building doesn't just magically hold itself up, right? It relies entirely on precise, high-tensile geometry.
Here's our agenda for today's explainer. We'll start with the core material advantage, then C and Z purlins explained, followed by trusses and roof battens. After that, we'll look at essential connectors and accessories, and wrap things up with safe handling and storage.
All right, let's dive into part 1, the core material advantage, the DNA of the build.
A structural design is really only as good as the raw material it's built from. You could have the most genius blueprint in the world, but if your steel isn't up to par, the project is compromised from day one. And we aren't just talking about generic metal here. We're looking at hot-dip galvanized steel. The minimum yield strength is an impressive 450 megapascals. In the real world, that translates to unyielding structural integrity under massive, massive loads. And when you pair that with a zinc coating ranging up to 275 grams per square meter, that isn't just a finish. That's literally heavy-duty armor against long-term rust and environmental degradation.
But it's not just about strength and fighting off rust, it's about ultimate safety. These components boast a Class O fire rating based on rigorous BS 476 testing. This is a top-tier classification, meaning there's a minimal surface spread of flame. When you're constructing a massive commercial building or a residential complex, this is exactly the level of tested, proven peace of mind you want integrated directly into the bones of your project.
Moving on to part 2, C and Z purlins explained, the heavy lifters.
So purlins are your primary support beams. They run horizontally across the roof, and their job is to transfer the massive weight of the roofing surface straight down to the primary building frame. These C and Z shapes are cold-rolled from that high-tensile steel we were just talking about. That cold rolling process ensures absolute consistency in their dimensions, and they're available in varying thicknesses from 1.6 millimeters up to a very robust 3.0 millimeters to perfectly suit your exact load requirements. But why the two distinct shapes? Why C and why Z?
Well, it all comes down to understanding the rule of contrast and how they're applied. C purlins are your go-to for simple spans. They have a really great standard box-up ability and connect end-to-end using standard butt joints. But Z purlins, they're a different beast entirely. They are uniquely designed with one broad flange and one narrow flange. Why? Because they are quite literally made to overlap. This makes them absolutely ideal for continuous structural spans over much longer distances.
Think of this as a quick engineering guided tour. When these Z purlins meet over a truss cord, because of that specific broad and narrow flange design, one Z purlin neatly slides right into and overlaps the other. They're then bolted securely through the web. This lapping creates a continuous beam effect, dramatically increasing the strength and the structural flow across incredibly wide building spans. It's just a beautifully elegant engineering solution.
Before we move on from purlins, I want you to burn this number into your memory: 25 millimeters. According to the structural specs, 25 mil is the absolute minimum distance from the edge of the purlin to the center of the first set of pre-punched holes. Out in the field, precision matters. If an installer ignores this tolerance, they seriously risk tearing the steel under load. It's one of those tiny details that holds the entire system's integrity together.
Okay, part 3, trusses and roof battens, the secondary framework.
Now, shifting our focus down to the secondary framework. This is the intricate network that actually interfaces with and supports your final roof surface, whether that happens to be heavy tile or metal sheeting. There's a fascinating detail to note here. Remember how our main purlins had a minimum yield strength of 450 megapascals? Well, the trusses and battens actually step up the material strength. These components boast an incredible 550 megapascals of minimum yield strength. They are thinner, ranging from 0.42 to just 1 millimeter thick, but they are exceptionally strong, ensuring incredibly rigid support right under the roof cladding.
If you find yourself needing even more strength from this secondary frame, engineers use a clever technique called the box-up. By taking two C-shaped steel truss sections and fastening them face to face, you create a fully enclosed, rigid box beam. This instantly brings extra strength, tremendous design flexibility, and the necessary stiffness to safely cover much wider spans without adding a ton of excessive weight to the roof structure.
Here's another absolutely critical installation number to remember: 150 millimeters. When you're installing the roof battens, those top-layer metal strips that your roof tiles or metal sheets screw directly into, 150 mil is the strictly recommended overlap length. Whether you're laying down a heavy tile roof or profile metal sheets, that 150 millimeter overlap guarantees the battens won't buckle or detach under the weight of the roof or the intense force of high winds.
Next up, Part 4. Essential connectors and accessories, the connective tissue. All of this incredibly high-tensile steel is basically useless if it isn't locked together securely. Enter the unsung heroes of the roof: mild steel purlin brackets and adjustable tie rods. The purlin brackets, complete with their multi-hole layouts, act as the sturdy junction boxes of your roof, bolting the purlins firmly to the main rafters. Meanwhile, the threaded tie rods provide crucial tension and bridging. They keep those massive, long steel spans perfectly aligned, preventing them from twisting or warping before the roof cladding is even applied. And how does all this steel actually attach to the building itself? Well, through heavy-duty anchor points, like the Angle Bracket 50. Made of galvanized iron, this acts as the ultimate anchor point. It secures the entire multi-truss steel system directly and firmly to the reinforced concrete beams of the building. This connection right here, where the steel roof and the concrete structure become one, unified, wind-resistant entity.
Which brings us to our final section, Part 5, Safe Handling and Storage, Protecting the Investment. You know, you can buy the most brilliantly engineered 550 megapascal steel on the market, but if it's mistreated on a chaotic construction site before it's even installed, your investment is already compromised. Let's walk through the non-negotiable site rules. First, you absolutely must exercise extreme care in unloading and stacking to prevent twisting or deep scratching, which can damage that crucial zinc coating. Second, keep it dry. Store it under a waterproof cover, but ensure adequate ventilation to stop condensation from building up. And finally, never leave it lying flat in the mud. Store these components off the ground on a slightly sloped position so that any trapped moisture naturally drains right away.
I also really want to highlight this specific, somewhat surprising warning straight from the engineering catalog. Listen closely to this. Avoid contact between galvanized steel and incompatible materials, specifically things like copper tubing. Mixing galvanized steel with copper on a wet job site is a complete recipe for a chemical reaction known as galvanic corrosion. It will literally eat away the protective zinc and cause premature structural rust. Keep them separated. So, as we wrap up this explainer, I'll leave you with a question. Are the bones of your next project built to withstand the test of time? Understanding the precise engineering, the overlapping strengths of Z-purlins, the raw tensile numbers, and even the chemistry of proper storage is what separates just a decent build from a true architectural legacy. Look closely at your current materials, demand precision, and apply these structural blueprints to your next major project. Thanks for joining me on today's explainer, and keep building smart.